and I'm going to be the primary presenter. So today's workshop is going to focus on numerical simulations using MATLAB. All right, and the way we are going to conduct this workshop is, I like to ask a lot of questions. We conduct these polls to basically get data in a much more organized way. But moving forward, when I'm asking a question, it would be great if you can type in your responses using the chat window. Most of you are in front of the computer. So if I ask a question, something like maybe it's a technical question or it's a non-technical question, and I would say that I'll give you time. I'll give you like 30 seconds to type in the response. Try to get in your answer by then so that I can read and then assimilate all the answers and then give a reply accordingly. All right. So welcome to the numerical simulations workshop by Skill-Lync. And most of you know us from this Facebook ad that you clicked on and then registered for this workshop. So Skill-Lync is an e-learning company that focuses on providing mechanical engineering courses. We are based out here in Chennai, and we do have an office in Wisconsin, USA. And what are we going to be looking at today? So primarily, I'm going to be talking about the importance of MATLAB and how useful is it if you want to say, do research work or do additional projects while you're still in undergraduate, still you are an undergraduate student, or if you're a working professional, how you can use MATLAB, or if you're interested in pursuing your master's in US or UK, or any other country, how can you use MATLAB? So that is kind of the main point here. And as and when I give you examples, I'll be talking about like, why are we learning this type of an example? Where is it that you will find an example like that? And for that, I've actually planned out a live demo. So first, I'm not sure if everyone is familiar with MATLAB. So I'll be giving like a basic usage demo where I'll talk about MATLAB, what you can use it for, and like, how can you use MATLAB from what you learned today? I think that is the biggest takeaway. Hopefully by the end of today's workshop, you learn some commands which you can put in place in your day-to-day learnings and start using the tool right away. Okay, and then we'll slowly, start solving different types of problems. Since most of you are mechanical, aerospace, or automotive engineer, we'll basically look at some math problems. And when we say math problems, we are basically learning mathematical concepts and how that can be solved using computer programming. And as I do that, I'll be explaining about the importance of solving these type of problems with respect to the industry. And then we jump on to building a simple simulator. Basically, we'll look at an auto cycle simulator that generates a PV diagram automatically. And then how you can modify this program to implement your own combustion models, which is an amazing project for a final year student. Then we'll look at a Rankine cycle simulator. I might skip that a little bit, depending on how much time we have. And then we'll also show you a robotic arm simulator. Like, this basically kind of shows a lot of the capabilities that MATLAB has to offer. So before we move forward, I would like to ask one question just to make sure that everyone understands where the chat box is and understands how to comment. How many of you are familiar with MATLAB? Or just explain to me about your familiarity with MATLAB. If you have never heard of MATLAB, if you've never used it, just say that you have never used it. If you use it day to day, just tell me how you use it, right? Again, take 30 seconds, type as big of an answer as you can, unless the answer is no. Never used? Okay, thank you, Dhirendra. Thank you, Jogesh. All right, thank you, Ashutosh. Thank you, Mehan. Cool. You used a bit during college days, not much. Sean, you're learning from the premium course. Okay, all right. How about others, guys? Not much. No, a bit. Okay, so I think it is quite safe to say that most of you are not familiar with MATLAB, right? I think that is the stance that I'm going to take. So let me just close this guy. And what we're going to do is we're going to check out MATLAB and then come back to this presentation later. All right. So let me just close this guy, maybe minimize the video feed a little bit. Okay, so I hope you can all see my screen. Now, if you're watching this through a mobile device, then things might seem very small because we typically want students to join these type of presentations from their laptop. So if you're using a mobile device, then I'm quite confident that this is going to look super small. The text is going to be even more smaller. If you're watching it on a laptop, make sure it's on full screen so that you can see what's going on. All right. So this right here is MATLAB. First of all, MATLAB is a programming language. And this is something that is being used by a lot of companies in India, outside India, and by a lot of research organizations. Why? MATLAB is super simple to use. I'm pretty sure you have all learned C or C++, right? So most of you commented that you have done some kind of programming, most likely have learned C or C++. And you might have struggled through the lab exercises where you have to write programs for matrix multiplication and things like that, right? So MATLAB makes it very, very easy. So the first thing I'm going to teach you is some basic usage. This will help you understand how MATLAB works. And in fact, if you're taking notes, write down some of the commands that I'm talking about, which you can actually use today. And from tomorrow, if you're studying subjects like finite element analysis, if you're studying subject like thermodynamics, your life is going to be much more easier. All right. So this is the graphical user interface of MATLAB. C program does not have one. MATLAB has one. That's the primary difference. So here, this right here is a command window. So the command window is basically like a calculator. So for example, if you basically do 5 plus 4, it's going to spit out 9, right? So fairly straightforward. You can use command window right today. Like also multiplication, division. If you want to use log, natural log, that's fine. Exponential, that works very well, right? So MATLAB is pretty neat at that. But the power of MATLAB comes from the fact that it can handle matrices. So for example, let us say that I have an array called density, right? I can just say that the density is 100, 200, 300, and 400, right? Now, volume, I'm going to create another array called volume, right? So I'm going to say that volume is 0.1, 0.4, 0.3, and 0.2, right? I'm just randomly typing in those values. So now let us say that I need to calculate mass. So density is nothing but mass by volume. So mass is going to be density times volume, right? So I can create a new variable called mass. I can just say that that is nothing but density multiplied by volume. Now, when we do the multiplication sign, I need to put a small dot in front. I'll explain to you what this is. But if you do that, almost immediately you get the mass values for all the four data points. Now remember, if you do something like this in C, you have to use a for loop. In MATLAB, you don't have to. Now here's where things get even more easy. In MATLAB, you can create arrays quite easily. So for example, let us say that I need to create a random volume array. I can use the ran command. I can generate 10 random values just like that. All right. Very, very powerful. Doing this in C program requires a lot of time. And one thing that you need to understand is MATLAB is an interpreted language, meaning you don't have to compile it. If you guys remember your C programming days, you write a C program, you need to first compile it. It creates an object file, it then execute it, right? It's kind of a two-step process. So whenever you make a change, you kind of have to do this entirely. But with respect to MATLAB, no, you can. It's an interpreted language, meaning as you type it, things are getting compiled, things are getting run by the processor. So fairly straightforward. So I have my volume array, and then now if I go back to the same command, right? If I type in mass is equal to density times volume, can anyone tell me what's going to happen? If I execute this command now, what's going to happen? It's going to show an error, right? That makes sense, right? Because your density array contains only 4 elements, whereas the volume array contains 10 elements. It says matrix dimensions must agree. And in fact, this is the important point. In MATLAB, everything is a matrix. So can anyone tell me what is the dimension of this matrix? So when we talk about dimensions, you have to talk about rows and columns, right? So it's not a single number. It's going to be 2 numbers. 4 cross 1 or 1 cross 4? Well, the answer is 1 cross 4. It's 1 row and 4 columns. Now, let's go to this guy. So for example, let's take the old value for volume. Let me just copy that. And I'm going to say that volume is now equal to the old value, right? So now volume is a 1/4 matrix and density is also a 1/4 matrix. So now if I execute this, if I just try to multiply these two, what's going to happen? I'm going to get an error, because what is the rule for matrix multiplication? Exactly, right? If you have 1x4 matrix, you have to multiply that with a 4x1 matrix, right? Else it's not going to work. So that's why we basically use an element-wise operator, meaning you're saying that by putting the dot in, you're saying that, okay, I have two vectors, they both have 4 columns. Don't do a matrix multiplication, do a dot product, which is basically what you do, right? If you have a vector A and B, if you do a dot product, what do? You multiply corresponding components, X, Y, and Z separately, right? And that dot is what you call as an element-wise operator in MATLAB programming. So everything is very well defined, and it has a similar sense to vector calculus or linear algebra, basically. So if you're good with linear algebra, most of the things can be carried forward. But the power of MATLAB doesn't lie just here. It is what happens if you have a larger matrix. That is where its true power comes in. So I'm just deleting everything that I've created so far. What I can do is I can create a matrix A, which has 3 rows and 3 columns, just like that. So now it's a matrix. Now remember, in C or C++, if you have to do this, you need to first create a program that can handle a matrix, which is typically your final project or your final lab exercise, right? So you're spending an entire semester to learn that. In MATLAB, just in 1 second, you can do that. What is the range of these random numbers? Typically, it's between 0 and 1. And if you see, that is kind of what is happening. It's always between 0 and 1. And every time you execute the same command, the matrix changes. All right. So let us say I have a matrix A, and let's create another matrix B. And let's say that it's also 3 by 3. Right? So what I can do is I can easily multiply the matrix just like that, A star B. And I can store the result in a matrix called as C. You don't need to allocate memory. You don't need to have 2 for loops. None of that. None of the things you have to worry about. You can just focus on results. So if you're someone who is working on finite element analysis, if you want to build your own finite element solver, one of the key steps you need to focus on is assembling the stiffness matrix, correct? How do you do that? Well, you can use MATLAB now. Similarly, if you're solving problems that involve matrices, if you're a robotics engineer, if you're an automobile engineer, if you're taking vehicle dynamics, then if you want to basically simulate a simple vehicle, well, there you go. If you want to be a robotics engineer, then you might be familiar with rotational matrices, right? For which matrices are involved. So amazing tool. Not only that, it has a lot of functions that can be used. So for example, if we have a system called as AX equal to B, how can I solve the system? If I have a linear system AX equal to B, how can I solve it? Can anyone tell me? Asai, I will answer your question in just a bit. But my previous question is, say that you have a system AX equal to B. How can you modify it, or how can you solve it? Exactly, right? So sure, so X is nothing but A inverse B. How do you compute A inverse? Again, to compute the inverse of a matrix, there are so many steps that's involved, correct? Now, in your first semester mathematics, that's what you learn. You learn how to compute the inverse of a matrix. And let me ask a question. To invert a 3 by 3 system or a 3 row and a 3 column system, if you're doing it manually, how long does it take? Right? In fact, that's part of your 16-mark problem or the essay problem, right? When you're taking your semester exams. So how long does it take to invert a matrix? Like when you do it in pen and paper? 5 minutes at least? Sure. So in MATLAB, I can just type in that, inverse of C, that's it. That's it, as simple as that. And in fact, you know what? Like modern day engineering, it doesn't really matter that you know exactly how to calculate the inverse. It matters that you calculate the inverse in a quick manner, because if you think about it, any type of simulation software, robotic simulation, computational fluid dynamics simulation, vehicle dynamics simulation, all involve solving a linear system at the end of the day, period. Or it could be even big data, machine learning, whatever. All involve solving a system of equations. So solving that system, you just, as an engineer, you need to know how to solve it. No one is going to question you how did you calculate the inverse. If you have a command, just use it. And that is why MATLAB is extremely popular. It is not popular because It makes your life simple. It's so popular because you can concentrate on the things that you're actually good at. If you're an automobile engineer, well, create a vehicle dynamics simulator. If you're a thermal engineer, well, build an auto cycle simulator. Don't worry about unnecessary details like how to plot, how to store the content, all that stuff. Right? I hope that makes sense. So it doesn't stop there. Same thing we can do with Octave too. Yes, in fact, Octave is basically a copied version of MATLAB. The only difference is Octave is a bit slow and it's open source. So yes, you're right, Deepesh. Sai Rahul, can we change the range of the random number? Yeah, absolutely, right? So if you think about it, the logic is actually quite simple. You don't need a separate command for it. So the question that Sai has asked is, when we use the random number, the number is always between 0 and 1, right? How do we increase that? Well, it's very simple. So what I can do is, say that I want it to lie between 0 and 10. I can just multiply all the elements in the matrix by 10. So now, all of a sudden, the values are between 0 and 10. Sai, I hope that answers your question. All right. So similarly, if you want to calculate the eigenvalues, easy. It provides a path for that. So there are so many commands, and the size of the matrix that you have to handle, it doesn't matter. However big of a matrix you have, MATLAB will be able to handle it. It's very, very powerful with respect to that. Now, where is this useful and how can you use it today? Well, if you're learning finite element analysis, or if you're learning robotics, as I said, you probably are working with a very simplified system, a two-link system or a two-body system, right? Because calculating that matrix, assembling that stiffness matrix takes a lot of time when you do it manually. So what you need to focus on is write a computer program so that you can actually do all of these things automatically. All right, so that is the type of learning you need to do. Because when you do that, think about it. Each and every subject that you take, you can do a computational project. In fact, that is what American engineers and engineers in other countries are doing currently. An average mechanical engineer from a US university completes 36 projects. How do you think they're doing that? They are struggling to do just 2 projects. Some of us just copy those projects. To do 36 projects, you need to put in a lot of effort. How can you do that? Learn computer programming and do your own independent projects. That is the way to go. Just learning a CAD software is not going to be enough. Because with programming, you can use your imagination and build simulators after simulator. There's a lot you can do. All right. So that is kind of the basic concept. So now let's do one more thing. Say that I have a random number and I want to plot the data to see what's the variation, right? Because that was the question that Sai asked originally. Very simple. So what I can do is I can just plot the data. I can say a plot of random and comma 10. There you go. Almost instantaneously I get a plot. Right? So what is the x-axis here? X-axis is the index. Since I have 10 values, it is saying that the first value is roughly 0.05, the second value is 0.4, the third value is 0.4. X-axis is the index and y-axis is the actual value of the random number. Right? I can create a plot just like that. And you can just make it a bit more prettier by adding a line width. Now the plot looks much more clear. And then you can actually add a label. You can just say that X label is X-axis. Y label is random number. You just do that. That's it. Extremely simple. Now this is another thing that you can start using right now. Wherever you have plots to make, start using MATLAB. All right. So that is basic plotting. In addition to this, you can do 2D plots and 3D plots. You can do pretty much anything that you want. It's quite easy to do in MATLAB. Okay, so now that we have covered the basic layout, let me go through a simple simulator, right? Because though I've told you what MATLAB is capable of, I've not told you like how to get started with respect to that. So let us say that we want to code an auto cycle, right? So I've already done the coding. So let me execute the program so that you can see what the final result looks like. There we go. So just think about it. In just maybe 3 or 4 seconds, I'm getting a PV diagram, right? Now, if you're solving it using pen and paper, you're taking maybe 45, 50 minutes, and plotting a PV diagram is impossible, right? You can just plot the state points, but getting the curves correctly is not possible when you do it using pen and paper. But a simulator like this is an extremely cool project to have in your resume. Not only it shows that you know programming, but you know how to program mechanical engineering systems, right? So whenever I tell this statement, programming mechanical engineering systems, immediately students ask, what is the point? Why do I need to learn that? Well, the answer is right here. So for example, this is today's search, job search for MATLAB and mechanical in indeed.co.in. I'm pretty sure everyone has heard of it. So just searching for MATLAB and mechanical, look at the number of opportunities you have and look at the job description. These are like core R&D oriented jobs. So Bosch, some local companies, some very good companies like FL Smith, Airbus, all of them require a lot of knowledge. So for example, here you can see that in Airbus in Bangalore, you see that there are opportunities where they require MATLAB and Skill-Lync, right? Knowledge and experience in simulation and modeling. Now you need to understand that in 4 years, you're not being trained at all on this, right? So if you're still in your second year, you still have time. So start learning MATLAB, because even if you look at the salary ranges in general, the minimum salary that you're looking at is 4.6 lakhs. Now, I'm not saying that just because you are learning MATLAB and you're able to write a simple program, you can get it. What I'm trying to say is if you're not even doing that, then you can just forget about working in these companies, right? So I'm pretty sure many of you are passionate about working in top companies like this. What I'm saying is that you need to be very good simulation engineers or modeling engineers so that you can take the idea that you have in your head, convert it into programs and get the results. If you're able to do that, getting a job in these type of companies is not at all hard. All right, so moving forward, how did I do this? Well, it's very simple. So you can see that I'm starting with, okay, so there is a question from Ramana Shiva. He's basically telling me that, hey, please tell me about the plot program one more time. Absolutely, Ramana. So for example, if you have two data sets, so let me just clear all, close and CLC, right? So this is basically deleting all the things that I've created so far. So let us just go back to the density example, right? I'm going to create an array for density. So I'll say that density goes from, it starts from 0, or sorry, starts from 1, goes up to 50, and there's 10 values, right? So this is my density array. Again, I'm using an array generator, makes my life extremely easy. And then if I'm computing volume using a random number generator, I can just say rand of 1, 10. And if I put the semicolon at the end, the output doesn't get printed. So for example, if I take the semicolon, the output is getting printed. If I add a semicolon, the output is suppressed. The value is still being calculated. All right, so what is mass? Mass is nothing but density dot star volume, right? We have already looked at this formula. So now I've computed mass. So let us say I want to plot how mass changes with respect to volume. I can just do plot. My x-axis is going to be volume and y-axis is going to be mass. That's it. The plot looks crazy because you're using random values for volume, right? You're not using straight, like you're not using linear values. So this is how it looks like. And then what I can do is I can just add a line with parameter. And the reason why I did that is to just make the plot look a bit more better. Okay, so Ramana, I hope this makes sense. All right, so let's go back. So what I've done is I've created state variables. So this right here is what you call as a variable in computer program. Now in C, you might have to declare the data type: integer, float, character, Boolean. Don't worry about that. MATLAB will figure it out automatically based on the value. So these are the things that makes your life easy, but as a result, MATLAB is a bit slow. Okay, so you used linspace and rand. Okay, Naveen, can you complete your question? And then what I'm doing is I'm actually taking the engine geometric parameters. All right, the engine geometric parameters like the bore, stroke, connecting rod length, and compression ratio. Now this is a key difference. When you studied auto cycle, you are most likely not taking into account these parameters at all. people directly provide you the volume at state 1 and the compression ratio. The reason why you start with all these parameters is that is how you work in the industry. In the industry, those are the values that you know, and you have to work from that. Okay, and then based on that, I calculate my swept volume, my clearance volume, and then I look at my V1, and then calculate my V2. Right, very straight. It is very similar to solving this problem using pen and paper up to this point. And then what I'm doing is I'm using some relations, thermodynamic relations, to calculate my second state variables, third state variables, and all that stuff. Again, I'm just skipping a lot of detail because in order for me to explain this, it will take me like 45 minutes to just explain this program, and I don't want to do that. So if I go down, I'm just plotting all the state points, and then I'm connecting the state points, which I'll talk to you about separately. And then that's basically it. So when I run this, I immediately get my PV diagram. What's the advantage of doing this? Well, if you have a program like this, then what you can do is, if I ask you a question like what happens when you change the compression ratio, how does the PV diagram change? Well, you don't have to guess. You can just run the program, and then you can tell me what happens. This is very, very cool. All right. Similarly, if you're talking about temperature change, I'm saying that after combustion, the maximum temperature change is 2800. What happens if it's just 2500? How does the PV diagram look? Well, you can see that it's becoming narrower, right? Because the work done is getting reduced. So there's not a lot of difference. The area is getting reduced, right? So these type of observations and these type of research is something that you need to carry on your own at an undergraduate level. I'm talking, if you're in second year, you need to be looking at this. Okay, looks like we have a couple of questions. First is the difference between linspace and random. Sure. So linspace is used to create an array between a starting number and an ending number, and the number of values that you want. So between 0 and 1, if I want 3 values, it's going to be 0, 0.5, and 1. That is what linspace creates. And similarly, if you want to create, if you use the random number generator, it will create 3 numbers, but all the numbers are chosen randomly. So this is basically ordered. It has a logic, it has a progression, but this one, it does not. It's randomly generated. So that's the difference. Deepesh, what is the question? So let us see. The question is, can you do 3D plots? Yes, absolutely. So for example, let us say that I create a random array, A equal to rand of maybe 20 random values, 20 by 20. And then I'm just going to multiply this by 10 so that my random numbers are between 0 and 10, right? And then what I can do is I can do something called as a surface plot. So surf of A, you just wait for some time, and almost immediately you get a 3D plot. You can rotate it, just look around the data. That's pretty cool. It's very, very powerful. Doing this using C or C program, C++ will take a lot of time. So Ramana Shiva, how can we solve partial differential equations? Well, I'm glad that you asked, because that is what I'm going to be talking about next. So you can see that building a simple Otto cycle simulator is fairly straightforward. We've done that. The next type of problem is basically math problems. Well, what are we trying to solve here? Well, I'm basically solving a simple elliptic partial differential equation. So for example, those of you who are not very comfortable with partial differential equations might not understand this. Just a second, guys. I need to make sure that my digital pen is connected. So I'm going to just stop my video for a second. All right, I'm back. I apologize for that. All right, so the PD that I'm going to solve is okay, Windows is not letting me. Dou square U by dou x square equal to 0. I apologize for the bad handwriting. My pen is giving me some problems. So can anyone tell me what's the analytical solution for this PDE? If I solve this PDE, what is the answer that I'll get? Again, so these are the types of questions that at an undergraduate level, you should be able to answer instantaneously. If you don't know, that's fine. Just type that you don't know the answer. Exactly, Megan, it's a straight line, correct? So it's a straight line. And to solve it, what we are going to be using is we're going to be using a numerical technique. So I'm going to be using Taylor series, and I'm going to discretize this guy. And I'm not going to go into the details, but the way if you discretize it, you will basically get u of x plus delta x plus u of x minus delta x divided by 2. So that would be the way to do it using numerical analysis. Let me just try clear all in this, and maybe I'll just open OneNote to see if OneNote is slightly a bit more easy to do. Okay, so this looks all right. So let me just delete all of this guy and then use the drawing functionality that's provided here. All right, so this is easy. So this is the PDE that I'm trying to solve. All right, so what I'm doing is I'm using basic numerical discretization. If you don't know, numerical discretization comes from Taylor series, right? So if you discretize this, you'll basically get u of x plus delta x minus 2 times u of x plus u of x minus delta x divided by delta x square. All right, so this is going to be equal to 0. So if I solve this for u of x, then I will basically get u of x plus delta x plus u of x minus delta x divided by 2. All right, so in other words, if you're using array indexing, again, since I cannot teach you like complete MATLAB in one day, I'll just call this as u of I plus 1 plus u of I minus 1 divided by 2. This is going to be the update. This is going to be update rule. And if I do this multiple times, does anyone know what type of an iterative solver I'm using? I'm using an iterative solver here. Does anyone know what's the iterative method? If you don't know, you can just type in no. That's fine. Ashutosh, thank you for your honesty. Raman Shiva, same to you as well. Okay, how about others? Since we have how many people on this call? We have around 18 people, so it would be great if all of you give me a response. This is not Newton-Raphson, so that's wrong. All right, so that's fine, guys. So this right here is basically your Jacobi iteration, right? Jacobi, Gauss-Seidel, SOR, you might have heard of terms like that. The reason why you need to understand or basically learn these type of things is because that is what is being used in the industry now. A core mechanical engineering, it's not enough if you just know, for example, things like, okay, these are the density values, density ranges for this particular metal. This is the melting point. And if you just know things like, okay, I know the formula for Hagen's pressure drop equation. Just knowing these things is no longer going to be enough. Especially if you want to get into a core company job, this type of questions are what is being asked today. Nowadays, mechanical engineers are being asked to code a lot. So for example, at an undergraduate level, if you're going for a shop floor engineer or a maintenance engineer, you don't have to know anything. Then your starting salary is at the range of 10 to 15,000, and most of them will get replaced by automation in the future. But coding engineers is what you require. A typical engineer who can code very well, who understand numerical analysis, you can expect a starting salary of 6 to 7 lakhs. And I'm talking about starting like right after BE. But you need to basically be able to understand whatever I'm saying right now quite easily. And the sad part is all of these things are covered in your first 3 semesters of mathematics, right? But I know that when people tell you about this, they don't tell you the background or application, which makes it very hard to learn these advanced topics. But it's never too late. Still try to focus on learning these type of concepts. You still have time, okay? All right, so I have this basic update rule. So if we go here, let us write a computer program for it. I'm first creating a 20 grid point system. This is a computational mesh. I'm creating a single one-dimensional computational mesh using the linspace command. I'm putting my boundary conditions. So for example, if everyone recalls Megan Patel's answer, it's Cx plus K. So there are two constants because you're integrating 2 times, which means you need 2 boundary conditions to evaluate the expression correctly. So you're giving a boundary condition at the first node and the last node. And then I'm starting my iterative solver, and there you go. This is the update rule, right? I had u of I plus 1 plus u of I minus 1 by 2. Instead of I, I'm using a j index. That's the only difference. Now, this is an iterative method, meaning it will start with a random value, but then over time, it will converge to the right answer. So for example, if I run the code, you can see that it starts with random values, but then as iteration progresses, it reaches a steady value and no longer changes. Let me run that one more time. That's pretty cool, right? We started with a random value. In fact, I can actually slow this down. So this is the beauty of MATLAB. You can actually slow things down to see how things are being solved. So let me slow this down 100 times. So you can see that how the random values are being changed. With each iteration, the value is improving. It is converging towards the final answer. This is what you call as converge, right? When people say divergence, that means that the answer is not tending towards the final answer. It's just continuously changing. It is not reaching a steady state. So this is a pretty cool simulation. I mean, it takes only 3 minutes to write, but it teaches you a lot about the importance of numerical analysis, and hopefully it is cool enough that you're interested in learning things like this in the future. All right, so I'm just going to kill this because this is going to take another 120 iterations, and you can see that we are already having a straight line profile. All right, so what do you guys think about the presentation so far? Would appreciate your comments. Like, what do you feel like when you see these type of simulations? What is going in your head currently? I would like to understand that. So please take 30 seconds. That gives me time to drink some water as well. Type in as detailed of an answer as you want. That would be great. Impressive. Okay. All right. It inspires me. Awesome. That's exactly why we are organizing these type of workshops. You need to get inspired first before you start learning something. Open my mind. Sure. Thank you, Sai. Appreciate the kind words. Cool. All right. So generally, positive outlook. No one is basically, dejected that they kind of missed out on the boat or something like that. So make sure that what career can we choose using this field? Well, that's the thing, right? The amount of opportunities that you have is just amazing. Learning numerical analysis, learning how to code, it opens up a lot of opportunities. You can work in manufacturing companies, automotive companies, energy related companies. Well, not only that, you can work for software companies where you actually get a mechanical engineering role. If you don't believe me, check for thermal management engineers in companies like Google and Facebook. In those companies, mechanical engineers are using simulation softwares to make sure that Google and Facebook's computers are safe, right? And to do all of these things, it's not like they're using MATLAB. They're using a CFD software like IcePack or something like that. But then they're writing scripts. They're writing scripts to test thousands of designs. And all those scripts are sometimes written in MATLAB or sometimes they're written in Python. But at the end of the day, they are both programming languages. If you learn one programming language, you can learn another programming language. It's basically like if you know how to extrude in SolidWorks, you can figure out how to extrude in CATIA in like 30 seconds, right? All right, perfect. So what is the next example that I wanted to talk about? The next example is, you can keep on doing this and you can build as complex as of a project as you want. In fact, I'm not going to go into the details of this particular project, but what I have here, it might seem very simple, is basically this code is actually a simple CFD solver. I'm pretty sure many of you have heard of ANSYS Fluent, all right, or ANSYS CFX. It's the CFD solver. What I've done is I've created a very simple version of that in MATLAB to solve the flow through a supersonic nozzle, right? Again, the complexity might be a bit hard to digest at this point, but let me just run the code. This might look very simple, but at the end of the day, let me just maybe add a couple of zeros here and rerun the code one more time. Sorry about that. There we go. So what I'm doing here is I'm actually solving for how the density, temperature, and velocity changes inside a supersonic nozzle. That is, just think about the capability, like think about the amount of work that you can do. Think about the possibilities that you will have if you have a project like this in your resume. And to do this, you don't have to, it's not like this is impossible at an undergraduate level. Students in US universities, some students in India are doing projects like this. Why can't you do it? And it doesn't matter which programming language you use. You can do this in MATLAB or C++. Just pick one, what we are comfortable with. And to answer Mihir's question, what is more important for mechanical engineering, C++ or MATLAB? I think that is a very wrong question. And this is why many students are not learning anything, because most of the time is spent in deciding which software to learn. Remember, it doesn't matter if you learn a great tool and if you're really shallow, meaning if you just know how to click buttons in a great tool like ANSYS Fluent, then your experience doesn't matter. But if you learn C++, but if you're able to code your own CFD solver, something like what I've done here, that is going to be far more valuable. All right. That is what you need to focus. So Ramana Shiva has asked another question, which is a nice question. Can you please tell me why we have to find eigenvalues and eigenvectors? So this is kind of taking a divergence or taking a tangent. I was talking about something else, but that's fine. So Ramana Shiva, when we talk about simulation softwares, right? So for example, if you take multi-body dynamic simulations, you're simulating a robotic arm, right? Or if you take vehicle dynamics, you're simulating a suspension system, how the knuckle moves and all that stuff. When you're doing this using a computer programming, what you're doing is you're creating a matrix. When you solve this matrix, you're getting the displacements and velocities. This is what you call as an equation of motion. The equation of motion is usually an ordinary differential equation because it's F equal to ma at the end of the day. F equal to ma, if you take acceleration, it's nothing but the second derivative of displacement. So d square x by dt square, right? You take that, you integrate it a couple of times, you get the answer for it. Now you have a linear system. Now the linear system has certain properties. Eigenvalues and eigenvectors are one of its properties. The reason why you look at eigenvalues is it basically tells you if the system can be solved accurately in a timely manner or not. That is why people look at eigenvalues for iterative solvers. All right. Now, if you're thinking about facial recognition application, for example, if you're using Snapchat or if you're using Facebook Messenger, if you look into the camera, it basically fits a face, right? How does it do it? It uses a technique called as it uses facial recognition. And how does that work behind? Like, for example, if you put a photo on Facebook, it immediately tells you that, hey, it's the photo of you, right? It's not like an engineer in Facebook is saying that, okay, this is Ramana's photo, this is Kunal's photo, this is Mehan's photo, right? No one's doing that. They use a technique called PCA. It's one of the techniques, a bit old. There are a lot of new techniques. It's called as principal component analysis. What, at the end of the day, though the workflow is very complex, the eigenvalues basically helps the computer recognize your face. Looking at the eigenvalues, it can basically say that, okay, this is the face of Ramana represented as a matrix. And the change in eigenvalues helps us understand the change in phase differences between you and me. Does it kind of make sense? And it's not only used in that, it's used in so many applications. For example, Google search. There is the original algorithm makes use of the eigenvalues. How to have continuous lines or discrete points. So Kunal, that's a very specific question and like might not be very useful for others, but so I'm not going to answer it right now. I'll just move on. If I have time at the end, I'll try to answer it. Cool, so I'll close everything. The next thing that I wanted to talk about is going to be slightly more impressive, hopefully. So what else can MATLAB do? And this is basically like if all the stuff that I talked about, if you rate it on a difficulty, like if I use a difficulty scale, and if I say that the difficulty scale goes from 0 to 10, the things that I talked about so far are difficulty level 1 or 2, to be very honest. In fact, I would just say that it's difficulty level 1. What else can MATLAB do? Well, you can actually use MATLAB to build your own graphical user interface. All right, so here, I'm pretty sure many of you might appreciate this, but this is actually a simple 2-hour robotic arm. So what I can actually do is I can perform a dynamic simulation here, and this has been built from scratch. The code for this graphical user interface has been written from scratch by mechanical engineering students like you. So what I can do is I can basically, I won't explain the details of it or the features of all the entire code, but I'll kind of show you what it does. This is basically a tool that you can use for motion planning, because not you, like you and I cannot afford to have a 2-hour robotic arm in real life. It's going to cost you several lakhs. So what I can do is I can just build a simulator like this, and then I can understand how the robotic arm moves. And as it moves, like how the joints change, this is called as motion planning or path planning, how that happens. All of this can be done in MATLAB. And you know what the crazy part is? You can actually use this particular computer program, interface this with a real life robo. Actually, this is actually a 1, 2, maybe a 4-link robotic arm. Apologies for the error. But this is the level or complexity of simulations that you can do. And on a difficulty level, I would say that this is maybe a 6 or 7, right? In terms of doing this. If you're able to do something like this, and then say that this is the only project that you have done in your undergraduate degree. If you go for your master's, I'm pretty sure that you'll get admitted into a decent university, and you'll also be given a funded admit, meaning you'll be paid to study, because this is the experience that people require. If you go and approach a company like ABB, which specializes in robotics, getting a entry-level engineer position is going to be extremely easy. Just show this project, talk about the things that you have done, talk about how you coded in the inverse kinematics, how you coded in the elbow in, elbow up and elbow down configurations, talk about how you solve the linear system. At the end of the day, a job is guaranteed. Focus on these type of projects. MATLAB is an excellent way to do that. And you don't need to spend a lot. You just need a computer, and that's basically it. Okay, so I hope that this inspires all of you to learn programming. If you don't want to learn MATLAB, if you want to learn C++, that's fine. But the easier option is going to be either learning MATLAB or Python, especially if you have never done programming. If you feel like whatever I'm showing you is a bit difficult, then stick with MATLAB or Python. All right, so I'm just going to close this guy. And this is kind of the code. You can see that this code is far more complex, because building graphical user interface requires a lot more knowledge. This is something that you do once you're quite comfortable with programming. Okay, so all right, so that basically concludes the presentation officially.